Welcome everyone to our fourth day of the winter camp. We're super excited. We have an interesting masterclass here. I wouldn't be the one to tell you about this. I'm gonna hype up the momentum till the time we introduce it. But before that, I would like you all to play a small game with me. As you can see, my background is not any wall or a window, right? It's a beach. Do you want to know why I have kept that as my background? Because that was one place I wanted to travel when the pandemic happened. And I missed that. I still haven't gone to any beach in the past 3 years. Similarly, I'd like you all to change your background as well, showcasing the place you really wanted to visit, but pandemic could not allow you to do that. It could be in your same country, it could be in your same state, anywhere. So let's get this engaging and change your backgrounds and show us where you wanted to travel. I see some backgrounds have started to change. I see a scenery for Renu. Renu wanted to go to mountains. Nirvana, you wanted to go and watch the FIFA match, football match. And for those who do not know how to change the background, quickly, bottom left, you see the video button. There is a top arrow. You select that. The third option says choose your virtual background. And you'll have plenty of options over there. I'll repeat again. There's a video button, bottom left. And on that button, there is a above arrow. Select that. And there will be an option to choose your virtual background. I see Alia wanted to go to a beach as well, or somewhere in States, if I'm not wrong. Anshul wanted to go there as well, back home.
I actually was over there during the pandemic.
Oh.
Yeah. But so I didn't follow your rules of the game. I guess I can change mine to outer space because I would love to be in outer space, just like my buddy Elias here. There we go. High five, Elias.
Oh yes, Elias has given you a high five. Well, great. They're quite interesting places. I see a resort next to the beach on the waters. Wow, lovely, fancy places you guys want to travel to. Great. So now we have an overall idea. Like, it wasn't just me or Anshul. It was all of us who missed traveling, right? Or we missed stepping out of the house. How COVID had been very difficult on all of us, right? But, well, that's fine. It was a learning on the human part for us. We realized what we've been missing out on. So we will talk about that and many other things which have happened during COVID, during the pandemic. I would like you all to meet my co-host, Anshul Baghi. He is the founder, CEO of Camp K12. Camp K12 is the one who's been organizing the camps for you and is also a global school online, which runs crazy classes helping you gain 21st century skills. Anshul, I'd like you to take over the platform and then go ahead with the session.
Sure. Thank you, Nishma, for the introduction. Hey, guys. Lovely to see all of you. And those who don't have videos on, please do turn on your videos. It just makes it so much easier for me and our main guest today, whom I'll be introducing soon, to see you and interact with you. It's a lot more fun for all of us. So those of you who have videos off, see if you can find that camera on button, use your webcam or your laptop. We would love to see you. But thank you for joining us. I think we're all in different time zones. We have our guest who happens to be in the UK at the moment. And we'll have some people in the US. We'll have a lot of people in the Middle East, in Dubai, in different parts of the world. So thank you for joining us from different time zones, guys. And welcome to this session. Hope you guys have been having an awesome time in winter camp so far. Guys, this session is not about me. My role is simply to introduce a master of the topic that we are discussing today, which is science and vaccination and medicine specifically. I think you guys know why you came here. We're going to have fun with science. We're going to learn how vaccines work. from an expert on the topic. And Nishma, I would request you to share the screen. Perfect, guys. So I'd like to introduce to you Keon. Keon is a graduate of Cambridge University in the UK. How many of you guys know Cambridge University? Raise your hand. All right. How many of you guys have traveled to the UK before? Yeah, we've got a few people who have traveled to the UK before, probably before the pandemic. So Keon was at Cambridge as a student. He actually decided to become a doctor, and we'll be asking him a bit about what that journey was like soon. And has always created impact for people around him throughout his life. And during a very difficult time during COVID, he was on the front lines, helping patients as a doctor. And he'll tell us a bit about that too. And today he is professionally working on drug development or medicine development. Today's session is about how vaccines work, a very relevant topic for all of us. But you should feel free to ask him questions about drug development, medicines in general, when you get a chance at the end. And guys, out of respect, I'm going to ask you guys to not annotate on the slide. Nishma, if you can tell us how to turn off annotations, we should do that right now, because I don't want children scribbling on the slides that are our guest chairs today. So let's take care of that before we start. How do we turn these off?
Yeah. Yeah. So if you see, I'll rather do
video
it.
Settings. Yeah, you can do it. Go ahead.
There's annotate.
Yeah, and just turn it off permanently for the session.
Yeah. Sorry, I'll do that.
No problem. And yeah, do it before Keon starts sharing his screen. We get so excited sometimes. You want to take notes and we start scribbling on the sides, on the edges of the slides. It happens, and it can be distracting for the others. So, all right, perfect. Thank you. So guys, without further ado, let me introduce Keon, our guest for today. And everyone, please welcome him with a round of applause for joining us bright in the morning, early at 8 a.m. from the UK. Everyone say hi, Keon. Hi, Keon. Say hi, Keon. We can't hear you yet, but we can see you saying hi. All right, perfect. So, Keon, why don't we just give you a chance to say hi, and maybe I'll ask you some questions just so that they can get to know you a little bit through our question and answer before we actually get started. And I think the annotations are still on, Nishma. So if you have a way of turning that off while we go through this, please do that. So, Keon, first of all, hi. How are you?
Hello, hi guys. Can you hear me now?
We can hear you loud and clear.
Thanks very much, Camp K12 for having me today. I think it's a great program. You guys are all very lucky to be able to be part of this boot camp. And I'm here, like Anshu kindly said, I'm here to talk to you a little bit about vaccines and a little bit about my background. And hopefully we'll have a bit of fun doing it and you'll learn one or two facts as well. Nice to see you all.
Awesome. So Keon, I think for some of us who are not in the UK, or most of us who are not in the UK, we'd love to get a sense of your environment right now. So tell us a bit about which city you're in. What's the morning like? Just give us a feel for your life at the moment.
Yeah, sure. No, this is funny because when you were all putting up where you want to go, I think one of the kids put up London, I could see, which is where I am at the moment. And as you've probably seen, the stereotype is pretty grey today. It's quite dark still. It's 8 a.m. here. I think it's probably lunchtime, midday for you guys, or a bit later. It's quite cold, so we're wrapping up warm. And the mood is fine, because it's coming up to Christmas. Everyone's very happy. But at the same time, which is what we're going to talk about a little bit, because of this new variant, this Omicron, I'm sure you've heard of, there's a bit of worry in the air as well.
Yeah, and I think because you're in the health circles, that all the information comes to you before it comes to everybody else. And I can imagine that worry starts in the medical circles before it spreads to the rest. So tell us a bit about, let's actually ask you a bit about earlier days. We're talking to an audience of kids today. Tell us a bit about where did you go to school? Like when you were the age of the kids that are in this room, which city were you in? What was your what was your school like?
Yeah, so I'll go probably slightly further earlier than that, because when I was 7, actually, so I came to the UK from Korea. I don't know if any of the kids have been or know anything about Korea, but that's where I was actually born. And then I moved to the UK when I was 7. And then since then, I went to school here throughout, and as Anshul mentioned, went to university in Cambridge as well, and actually grew up in Cambridge. Again, I don't know if any of the kids have been to the UK or Cambridge, but it's a lovely little town, very green, lots of cows around. So it's a good place to grow up.
Yeah, beautiful campus. If you guys want to go to Google Images after this and check it out. Keon, tell us a bit about what it's like to study at Cambridge. It's one of the most talked about universities in the world. What was it like for you being a student at that university, and what were your peers like, and what does it feel like to be a student at such a university?
So I think the main thing is what everyone says is it's like Harry Potter. I don't know. I'm sure there are some
Harry Potter fans.
Exactly.
Yeah, it's like Hogwarts probably, right?
Exactly. Yeah, Sumil, he's a Harry Potter fan. It is like that because the buildings are hundreds and hundreds of years old. You walk around at night, sometimes it's quite spooky even. But beautiful buildings aside, it was a great place to study. Lots of good subjects, lots of great teachers. And, it's full of, Anshul asked about my friends and peers there, and it's kind of similar people, people who want to learn, but also who want to have a fun time as well. So kind of the kids here today, actually, who are giving up some of their holiday time to kind of learn, but also have fun at the same time. So it's the similar kind of environment.
And you decided at a very young age to go down the medical track. It takes a lot to be a doctor. I think some of the kids in this room, in this session, will realize, should they go down this path, that there's a long process of studying, taking exams, and a lot of things you have to do to become a doctor. Why did you decide in these years at Cambridge, and how did you end up deciding that you want to dedicate your life to this field and to becoming a doctor?
So Anshul's right. It does take quite a few years to become a doctor. I don't know if there are any budding doctors in the audience, but I'll say
anybody. Actually, let's ask how many of you want to be a doctor when you grow up and go into medicine and science in general? Yeah, we've got Mustafa's a maybe, Rishabh's a maybe, and you're not expected to know this. I don't know if Keonwoo, you knew if you want to be a doctor when you were in middle school or high school. Actually, that's what we would love to ask you. When did you figure out that you want to become a doctor, and how?
Exactly. So I was quite late. So you guys are well ahead. I actually knew when I was probably about 15, 16. So quite a lot older than I think most of you here. And the way, excuse me, and the way I decided was I knew I wanted to do something important in the sense that it helps other people. A lot of people at that age, culturally here as well, it's kind of about making money in a way, but I thought I wanted to do something that had an impact on other people as well. And I liked sciences at that age. So I just put the two together, and it was kind of the clear choice to do. And I want everyone to know that, being a doctor, everyone thinks you work in a hospital and you see patients, which is true, but there's actually a wide variety of things doctors do. So it's worth having a look at, and it gives you options to do lots of things as a doctor.
Nice. So I think let's fast forward in the interest of time. You ended up you ended up being a doctor and on the front lines during COVID wave 1 and wave 2, I would imagine. And when you and I were talking earlier, you did mention you were working directly with patients. Tell us a bit about what your role was during the COVID phase and what you were actually doing on the front lines, and maybe also tell us about what kind of doctor are you?
Yeah. So that's very good. So kind of what I said to everyone, which is there's such a variety during training. I was actually on something called ICU, which is intensive care unit, during the first wave. So when we were talking earlier about, wanting to travel and stuff, I was stuck here as well. I didn't get to go anywhere, and I was actually stuck on something called ICU. And for the kids who are not sure what that is, it's where the sickest patients in the hospital go. Essentially, you may have seen it on TV. It's where all the tubes come out of their mouths and stuff. So that was obviously quite tough during the first wave because of the volume of patients, and also at that time we didn't know as much about COVID. So there was real fear in the air about, is this really going to wipe out a lot of the population, and also is it going to impact us, the healthcare workers as well. So doctors and nurses were getting quite emotional as well. So all that aside, it was a great team. You kind of look after each other as well. You know, we've all got friends here, and that's how we kind of got through it as well. And second wave was quite similar. So that was my role in the first and second waves. And I'm sure you asked about what I do now, which is a bit different. Shall I go on to that as well?
Yeah, go for it.
So what I do now is slightly different. I've moved away from the wards, so hospitals. And as Anshul mentioned, now I work at somewhere called Pfizer. Does anyone know what Pfizer is or heard of Pfizer before?
Maybe in the context of the vaccine, they would have. I feel like Pfizer as a brand has become quite prominent because of the role they played in COVID.
Exactly.
Consumer.
Great.
Yeah.
Lots of hands up. I can see on my screen anyway. So good. So Pfizer, yeah, like Anshul mentioned, it's become quite famous because of the vaccines lately, and that's very good. You guys are clearly very clued up on the news. I don't think I watched the news so much when I was 10. But even before vaccines, Pfizer is basically a company that makes medicines, lots of medicines. So all sorts, you know, cancer medicines, which is what I'm working on now, you know, all your vaccines as well, all your other infective medicines. So that's where I work at the moment in drug development.
Well, on behalf of all of us, Keon, thank you for your service, and to your peers as well who are working on the front line with you. Thank you for helping out the community in a difficult time like that. And also thank you for making time for this session today out of what I imagine is a pretty busy schedule for someone who is a doctor. And so excited to have you here with us. And guys, you have a little bit of context now on Keon's background, and I think you know why he's the perfect speaker for the topic we're about to discuss. A very relevant topic, which is how do vaccines work? So Keon, over to you. Thank you again, and we're looking forward to learning from you.
Great. Thank you very much, Anshul. And just before I go on, so the point is to have a bit of fun learning about vaccines, okay? Because it is a super cool topic. You know, you've all been affected by it. And I think, who's it? Saeed. Hi, Hussein. Saeed said his parents got it. So all our family's been impacted by it, okay? So we'll have a bit of fun on an important topic. And going forward, any questions when I'm talking, pop it in the chat, and I'm happy to be interrupted and talk about it as well, okay? And we'll try and make it interactive as possible. So how can I start the slides, Anshul? Have you got slides for me, or should I share my screen?
You can share your screen, yeah.
Okay. Right. Can everyone see that?
Yes, we can see it. And you can always go into presentation mode.
Yeah, let's do that. There we go.
Perfect. We can see it. Yeah.
Good. So, like we said, we're going to talk about vaccines today, and I've talked a little bit about myself. And before we go on, let's see, actually, Sai's mentioned already, but has anyone received any vaccines in the audience today? Just raise your hand on Zoom if you have, or remember getting some. Good. Lots and lots of people. Good. Lots and lots of people. Good. That sounds about right. So I'm surprised you remember it all as well. I just have a little scar on the back here, so I don't really remember getting it, but that's good. So lots of people have been having vaccines here, which is, like I said, we don't really know when we get it, but it's protected all of us from very nasty illnesses, and which we'll go on to talk about. A little bit of a warm up. So we've all heard about COVID-19 and COVID-19 vaccine as well. And here, everyone can see the picture on the right. So they're all little COVID-19 vaccines, essentially, and they all look very similar, but can anyone see any difference in them? And just pop into the chat if anyone can spot differences. Or if there's anyone brave, you can speak out as well, just unmute. Good. Lean saying different brands, Arian different companies, different brands. Good, exactly, spot on. We're all wide awake. That's just me actually, isn't it? It's 8 a.m. You're all, it's at lunchtime. Perfect. that's what I was getting at. So different companies. So you can see the first one's Pfizer, and the second was Moderna, and etc. And we'll go on to talk about why that's important, because they all do the same thing. They protect against COVID-19, but they work very slightly differently because of the company they're from. Okay, so really good. And so that's where we are now. But how did it all start? So this is a very old picture. I think the picture is actually from about 1500s. So in the UK, that's kind of Tudor time. And it shows a man with blisters all over his body and some kind of pin they're using, depicting basically using a sample from the spot to vaccinate someone, an early form of vaccination. And essentially, it's just to show that vaccinations have been with us for a long, long time. Not, you've heard about the COVID stuff, but it's been here for thousands of years. And some counts go up to 200 BC, so Roman times, some form of vaccinations have existed. Okay, so they've been around for a long, long time. But a little quick history lesson. I will try and make history fun. Not just dates and events, but try and make it fun with characters. So in the West, in Europe at least, this man, Edward Jenner, has anyone heard of Edward Jenner before? I'll be very impressed if they have. Oh, wow, some people have. Mohammed has. 6 people have. That's really good. Lots of people have. Like I said, you guys know a lot more than I did when I was your age. So Edward Jenner, as some of you have heard, was a doctor. He's known as the father of vaccinations in the West. And essentially, he did a lot of things, but what he did was notice something very interesting. He noticed that milkmaids, so, the girls who kind of get milk from cows, they never got something called smallpox. Smallpox was a nasty disease back in those days, so 1796, okay? And when he noticed that, he asked a question, and that's the key thing we need to do with science. You make an observation, so you see something happening, and then you always have to ask why that's happening. And that's essentially what he did. So he noticed, and then he came up with an idea, and he thought, this is because milkmaids get something called cowpox, which is a less serious version of smallpox, okay? And they get this from the cows. And somehow getting this initial cowpox disease protects them from the actual deadly disease of smallpox, okay? So that's what his idea was. And then he tested this. So he found a milkmaid called Sarah. She's milking away, and she's getting cowpox from the cows, okay? And you can see the blue dots on her skin. And then from the blue dots, they get a sample from it. And he finds a poor boy called James Phipps and rubs the sample all over his skin, essentially, to infect him with cowpox, okay? These things won't be allowed now, but this is how it used to be done back then. And the boy got cowpox, and he had a mild illness from cowpox. But after cowpox, for Jenner to complete his test, he found someone with actual smallpox, the deadly one, again, got some blisters, got some samples from the hand, and rubbed it all over James. Again, shocking thing nowadays, because this could have been dangerous. But luckily, his idea paid off, okay? So because the boy never got smallpox, he was protected from it. And that essentially is how vaccines work. And he was the first person to put it into kind of real life demonstration, okay? So that's how it kind of all started in the West. And we've come a long way. So quick quiz here. So both of these boys, probably, early teens, have been exposed to smallpox, the disease I was talking about. One of them have been vaccinated. Just pop into the chat which one, left or right, has been vaccinated, do you think? Let's see if I can see the chat. Perfect, spot on. This is too easy for you guys, isn't it? Good, spot on. It's exactly the right side. Everyone's got it right, and this is quite clear. It's quite a stark example about the power of vaccinations, okay? That's all it was, a small injection, and the right boy on the right protected from it, boy on the left very, very unwell from it. So I want to kind of remember this image about the power of vaccinations. So that was smallpox, like I said. So now I'm going to take you on a journey into the body, essentially, to explain how this all happens. Small injection, but then how do we get protected from all of this? And I need to introduce some characters, some main players in this. And the first one is this little spiky friend, not friend, actually foe. Does anyone know or can guess in the chat box what this thing on the left is, these little spiky balls? So most people are saying, yep, good, virus, capsid, corona. Wow. Maybe I should do the high school version. This is very good. Yeah, exactly, virus, good. So most people got that right. So it's a virus, essentially. It's a small ball with spiky proteins coming out. And that could be any, so there's many types of viruses, okay? This could be the common cold we get every year. This could be coronavirus. Obviously, at the detail, they are slightly different, but this is what a virus looks like. And on the right, if you can see the diagram as well, if you just move the screens a little bit, is a very simplified diagram of the virus, okay? And all a virus is essentially DNA or RNA, which is the genetic material in the middle, protected by this protein coat on the outside. It's their fancy coat to show everyone who they are. It's a very unique coat each virus has, okay? So that's the virus, player number one. Oh, someone's having a draw, that's good. And this is the other key player in this whole fight, okay? So there's actually two things here in the diagram. Can people guess what this, if you can see my cursor, this thing is, and the big white thing is as well? Just pop into the chat. Again, you guys are all very good, so I'm sure. Good. Good, exactly. Most people are getting both right. Red and white blood cell. Very good. Very good, very good. Again, I'm saying I was very impressed. I don't think I knew things like this until I was in early secondary school, like year 7.
It is indeed inspiring.
Very good.
This crowd, yeah.
Yeah. You're all right. So the big white thing, as the color suggests, is a white blood cell. And the red thing is the donut-looking thing is a red blood cell, which carries oxygen around our body. The key thing we want to focus on is the white blood cell. And these are, if you like, the soldiers that fight against infections when they invade our body, okay? And this is going around our bodies all the time. We don't realize it, but it's protecting us all the time. And there are many different types of white blood cells. And you can think of them as, soldiers in a way in our body. So here you can see 6 different types. They work slightly differently depending on the kind of infection and depending on where the infection is. But essentially, they all protect us from infections, okay? And yes, they are the heroes of our immune system. And I'll tell you a little story actually to show you how important they are, because when I was working as a doctor on the hematology ward, so that's the blood ward where patients with leukemia, things like that, come. So very unwell patients. You may have seen, patients with hair falling out. And some of the treatments, we have to get rid of their immune system to give them a new immune system, because sometimes the immune system is the problem. And the point I'm trying to make is, during the process, there's a brief period where we destroy their immune systems in a controlled way. During that period, those patients get very, very sick, okay? And they get infected by things that we wouldn't even notice. So things like even the common cold, all of us, you guys as well, we get it yearly, we shake it off in a few days. Things like that can kill them and have killed them, okay? So that's just to highlight how important these white blood cells are. We don't see them, we don't notice them, but they're always protecting us. So moving on, how do these white blood cells work? So they work in very complex ways, and I'm sure many of you will go on to sciences and even discover more about how they work for us. But one of the ways we do know how they work is through antibodies. And this thing on the left diagram there is an antibody. It's a very small protein, a Y-shaped protein, as you can see. And it has a section where it binds to viruses or foreign particles here and here, okay? And how they work is when a virus invades our body, as you can see in the second diagram, it goes and finds these viruses and sticks onto them, onto those, the protein coats I told you about, the little spiky bits. They go and stick onto them, light them up, and what they do is they tell the white blood cells there's an infection, and here it is, okay? And the white blood cells come and destroy the viruses. So in a simple way, that's how it works. So antibodies stick to viruses, show up to the white blood cells, and the white blood cells destroy the viruses. So I've got some hands up. I don't know if they're questions or from the previous one.
I think you can do it all at the end. You can take questions at the very end. And guys, if you have a pressing question related to the topic he's discussing, you can write it in the chat thread. That way we can always, either Nishma or I can jump in and ask Keon to answer it.
Okay, cool.
So if you guys have a pressing question, ask it on chat. Otherwise, we'll give you a chance to ask him at the end. Antibodies, green things, antibodies.
Yeah. Fine. And just going on a bit more about how antibodies work, because this part is very important. So antibodies work very specifically, okay? And this diagram shows that an antibody detects one type of virus. So you can see in the first one, the pink one, when there's a measles infection, there's an antibody specifically that recognizes measles particles, okay? And from the shape, that's what it's trying to show you. It recognizes that. And again, for example, chickenpox, if you had it before, you'd have an antibody that directly recognizes only chickenpox, and etc. For example, the chickenpox antibody will not recognize measles, okay? So antibodies work very specifically, and that's very important when we talk about, how we develop this immunity after a vaccination and how we become immune to, say, COVID-19 with those COVID-19 vaccinations. And that's shown here in the last one with the green particle. If there's a new infection, we don't have antibodies to it yet. So say, COVID-19 infection, someone gets it for the first time, they either get very ill with it and then eventually fight it off, or if they can't, they die. So that's why it's very important to know antibodies work very specifically, and we need to develop antibodies specifically to a pathogen, which is a foreign organism. So that's how antibodies work. How do vaccines work? Okay, hope everyone's still with me. I think there's a bit of a range where some kids obviously know a lot more vaccines, and some, kind of, this is all good level as well. So I'll keep explaining as much as I can. So now you know a bit about how antibodies work, okay? And what a vaccine does is, all it is, if you like to simplify it, it's a fragment of the virus that we introduce to the body. Okay, a little bit like what Edward Jenner did all those years ago. You introduce a bit of something similar to the actual virus to a body, and the body amazingly produces antibodies towards that foreign body, that protein, okay? So that when you get an actual infection with the whole virus particle, which is the dangerous particle, it already has antibodies to that virus, okay? So it's already ready to fight off that infection. And that's key in, someone going to hospital and passing away versus someone having maybe a very mild flu illness and then shaking off COVID, for example. Okay. So just to recap, all you need to remember is a vaccine is a small fragment of the virus, a very undangerous particle, goes into the body and prepares your body to fight the infection by making antibodies. Okay. So that's how vaccines work, and this is just to recap in the schematic way. So we all know how we get it. So it's injected into our skin, where small fragments go in, and that causes antibodies to form. And I think the key thing is the third diagram here. So when you actually get infected by the virus or other pathogens, the antibodies are already there to fight it off. Okay, that's the key thing. They're already ready. Okay. And the other key thing I'll mention here is something called memory, okay? The white blood cells that produce antibodies do an amazing thing where they remember that they've been infected by this before, okay? So that's why a lot of you would have had vaccines when you're a baby, okay? And your body's remember to produce those antibodies, and it remembers those pathogens. So when you're older and you get infected, you don't notice it, or you get very, very mildly ill, okay? So white blood cells remember your previous infections. And with this mechanism of working and development, we've come a long, long way, where there's vaccines for a lot of things. And vaccines are, like I said, in the world of science, it's really one of the biggest achievements I think humankind has achieved. We've got vaccines against polio. Polio's been wiped out of the world. Hepatitis B, measles, rubella. And a lot of these are things you would have had as babies. You probably won't remember, but it was in the jab where you got when you went to hospital as a baby. And just to recap, this is kind of an extra section, I think, because some kids clearly know a lot more about vaccines than others as well. So this is kind of like the bonus section where if we bring it back to COVID-19, because that's where we're kind of focusing on at the moment, back to the front, back to the first slide, there are a few different types of COVID vaccines depending on what company makes them. And they work slightly differently, okay? So for example, you can see the first one is a viral vector, or the second one is an RNA, which is the genetic material vaccine, okay? To keep it simple, essentially, one of them uses a very harmless virus, which could be the common cold, for example, which we know don't kill us, and put in a small part of the COVID-19 genes and then give it to us. So once in our bodies, it replicates the COVID-19 protein and we develop antibodies against it, okay? And the other one is where they actually just put in the genetic material, so RNA of the COVID-19 virus to our body. And then once in our bodies again, it replicates. And once the proteins are made, our body produces antibodies and form immunity towards it, okay? So that's just to keep it simple how they work differently. But in essence, what you need to remember, the principle is the same. Whichever way they introduce it, it introduces a fragment of the virus protein into our bodies and prepares our immune system to make antibodies. And this slide is just to show a little background about how we all actually make this. This is all good and well thinking about the scientific principles, but what does it actually take from theory to the little vials you get in the hospitals that you get a jab in? And the short answer is many, many years and a lot of money as well. Just to put it into context, most medicines and vaccines used to take about 10 to 15 years to make from the idea into the actual vaccine. And money-wise, it could be a lot, okay? Just to put it into context as well, because I was surprised when I first knew. It's ranging from around $500 million kind of figure to make a new medication to get through the whole process. So a lot of clever scientists, lots of doctors, lots of patients as well involved in this. And I'm sure a lot of you will, if you're interested, will get involved in the sciences to help this discovery. And you don't have to be a doctor, by the way. You can be a scientist. And in fact, lots of scientists actually work on this research as well. And just to show what the power of good teamwork is during the COVID-19, when there was an emergency. I said it took 10 years usually. The first COVID vaccine by Pfizer was made in about a year, just over a year time, which is, I know that doesn't feel real, but that's actually phenomenally faster speed as well, okay? So what I'm trying to say is if we get smart kids like you into research, good teamwork, we can make lots of new vaccines, that your parents can get, you can get, and eventually your kids will get as well. So we can go traveling to all these places, all these sunny beaches, more and more, okay? So I want you to kind of think about what you want to do as well. And also the other thing to think about is vaccines. A little bit painful when you get it. Like this girl, she's being very brave, but phenomenally good at protecting our bodies, okay? Very important, one of the biggest discoveries we've made as a humankind. And I won't go back to the picture, but just remember that smallpox with the two kids where one kid has all the blisters, the other one doesn't. Because me and you, we're all people who kind of remember visual things, I think. And that's the power of vaccines, all the blisters versus nothing, essentially. Okay, so that's the end of my little run through about how vaccines work.
That was very enlightening for me personally, and I can imagine that for all of the students here, I think we all learned a lot. So Keon, thank you. You guys are hearing it directly from someone who worked in the field helping patients through the COVID time and who works on development of drugs and medicine and vaccines today. As you were talking, Keon, there were a couple questions. I have jotted down some of them. And what we can do is we can invite some of the kids to ask those questions.
Yeah.
So let's go into the Q&A segment now. I remember that Mustafa, you had a question. So if you are here, Nishma, if you can see Mustafa, if you can unmute him and let him ask his question. I think I see him. There he is. There you go. Mustafa, I've asked you to unmute yourself. Go ahead and ask your question.
Okay, thank you, Mr. Yu. I really loved your presentation. It was extremely informative. I actually have 3 very short questions. Believe me, they're very short. The first question is, do you know why COVID affects adults and older people, including elderly, more than us kids?
Yeah, I'll go with that first, and then we can answer each other. Thank you, Mustafa, and I'm glad you found it useful.
Hey, Kioni, before you answer, can we ask Mustafa to tell us what grade he's in, or how old he is, and which city he's in?
My grade is, I'm in year 7 in Dubai College, and right now I'm living in the UAE in Dubai.
All right. Thank you for the questions. Go ahead, Kim.
Okay, year 7. So that's a very good question, Mustafa. And my answer to that is essentially, so viruses affect patients differently depending on age, and that very specifically depends on the virus. Some viruses affect kids more, some affect adults more. But on the whole, in general, the older we get, our immune systems get a bit weaker. That's why you've seen elderly patients get lots of other diseases as well. That's why, like you quite correctly said, COVID affects elderly patients more. So in terms of frequency and in terms of severity, and that's because their immune systems are generally a bit weaker as well. Does that answer your question? Was there a second part to that?
Is he still unmuted? Maybe we can't hear him because he's back on mute. Mustafa, oh yeah, he's back on mute. Someone muted him. Go ahead, Mustafa.
Yes, thank you. I was trying to signal that I was on mute. My second question is, Mr. Yu, you said you did some work with patients during the first 2 waves of COVID. My 2 questions are, out of the 4 vaccines you showed us on your presentation, which do you think are the most strongest in your opinion? And have you given any COVID vaccines yourself?
So very good questions, very insightful questions. A lot of things that scientists are asking, essentially. So I think the way to think about it is, because you said strongest vaccine, which is, I see what you're asking. So in terms of the scientific word is efficacy, if you like to learn that as well. It's about how effective these vaccines are. And actually, a lot of them have similar efficacy in terms of how strong they are, okay, in terms of how much protection they give. So the Pfizer one and the Moderna one, for example, very similar, and AstraZeneca one's quite similar as well. Technically, the Pfizer one apparently gives a bit more protection than the other ones, okay? But what I want you to remember is, it sounds like you're a budding scientist, which is any medication we give, including vaccinations, has side effects, okay? And sometimes that's the key thing to remember as well. It has to be safe. We don't want to do more harm than that the patient's already in. And one of the things, for example, with AstraZeneca, one of the things we noticed was that people get blood clots. Very rare again, very, very rare, but a bit more than the other brands, okay? So that's when we had to change strategy a little bit. And I'll tell you this bit as well, because I think you know quite a lot about COVID, which is with the younger patients, we had to stop giving AstraZeneca ones because it started causing blood clots, okay? We don't know why exactly yet. It's starting to come about why we think that might happen, but that's why we had to change tact. And for them, we'd give the Pfizer ones, for example. So just to summarize, you think about how strong it is, but also how dangerous it might be as well. So that's how we make the decision. And did I give vaccines myself? I didn't actually give vaccines myself. I received one and I gave other medications, but not vaccines myself as well.
Thank you for the questions and for the answer, Keon. I'd like to go to Alia Todi next. Alia, you asked a question on chat, which I thought was very insightful. So please unmute yourself.
I have a question, like, how did the COVID vaccine get produced in 1 year, and most of the vaccines get produced in like 10 to 15 years?
Before you answer, Keon, Alia, once again, you have to tell us which city you're in, what year you're in.
I live in Dubai and I'm in year 6.
Okay.
Great. Again, very good question as well. That's something that the whole scientific community has been working hard actually in the last few years to do. And in answer to your question, it's essentially what it is the 10 years, because you'll have to know a little bit about what happens in those 10 years to see what we could kind of reduce in time. So in 10 years, there's research, for example, and there's testing of that drug as well. And then there's a lot of admin stuff. So bureaucracy, paperwork, regulations as well. Okay. And the short answer is all of those steps, which usually take a few years, and added up to 10 years, were shortened massively. Okay. So there was collaboration in the research part, where information between different labs and stuff were made quicker. And the tests were, what's the word we use in Pfizer? Were done in light speed is the word we use. Okay, so people were working harder as well, and trials were done quickly. Patients were recruited quickly, for example. Like I said earlier, patients are very important in this development. And the third part, in a way, potentially most time saving, all the regulations were done very quickly because this was a politically very important event as well. And frankly, an international emergency. So all the regulatory bodies work very quickly to reduce that time as well. So in answer to your question, every stage, there are a few stages, were all shortened by several years and done very quickly. And it's a lot of people working very hard as well.
And I have one more question.
Yeah.
Why are vaccines like normally done on your arm and like not anywhere else on your body, like on your leg or something? Why always the done on the like your
Good question. You know what? There's no reason, because the arm is accessible. I think you might remember, you probably don't remember, when you're a baby, we used to get on our bottoms as well. Okay. So it doesn't have to be the arm. It's just the arm is very accessible. As long as there's enough skin and a bit of fat, a bit of muscle going, you can imagine if we're going to a bony area, it's going to hurt a lot and it's not actually going to get to where we want. So it's just anywhere with a lot of flesh, but arm is easy to stick out, then I guess your leg.
Thank you for answering my question.
Thank you for the question. Next, let's go to Renu, who has more of a personal question. And let me find you, Renu. Let me figure out how to unmute you. Go ahead, Renu. Tell us which city you're in and what year you're in.
I'm in Dubai and I'm in grade 6. And I was asking you that, was there someone who inspired you to be in this field of medical science?
I think so. Thank you very much for your question. I heard that as, did someone inspire me to be in this?
Or like what inspired you to go down this track?
Yeah, no, very good question. Yeah. Very good. I'd say it's linked to why I went into medicine in the first place, I'd say. I think I wanted to do something important and impactful for as many people as I could, so humankind. And one of the ways to do that is through science, I think, because science is the same whether you do it in London, whether you do it in Dubai, okay? Vaccinations here, we use the same thing as we used in Dubai, okay? So that's why I thought through science, I could make a big impact and hopefully contribute something as well. So I want you guys to think as well, think big, dream big, and not everyone has to go into science. Obviously, some of you will be arty and that's brilliant as well. But through science, you can really make an impact in a bigger scale as well, okay? You do great research in Dubai or anywhere in the world. the international science community is quite small. You know, all these papers and journals, we all read the same thing. So you can make a huge impact. Okay. So that's why that was my dream as well.
Thank you, Keon. And thanks for the questions, guys. Hey, Nishma, I think we have just 5 minutes left for the event. So I'm going to ask you to just close it off and let us know if there's something else that you would like to do.
Well, yes, I think before we jump onto that, I'd like everybody to celebrate and congratulate and rather have a thank Keon for delivering such an insightful session. We can do a virtual clap. We can do a celebration reaction. Thank you very much, Keon. This was, I think I was reminded about my science class, which I had forgotten long ago. Great. Right. So moving further, as in the beginning, I had mentioned that there's a challenge for you all, right? Now, we'd like all of you to share a photograph of your inspiration, like how you asked Keon, sir, what inspired him. We'd also like you to know that what inspires you. Share a photograph of that. Either you're in that inspiration zone, or you have drawn it, or you have written something about it. Anything which talks about the message, what inspires you, and you should share that with us on our Facebook channel. Now, how do you do that? I'm quickly going to share my screen and show you the instructions. Do you see my screen? Yeah, okay. So we have an online community of Camp K12. You can share that here. You have to first sign up yourself with the community. I'll share the link with you in the chat. After that, click a picture. Like I said, what you've drawn, if you're in, or you're in that area which inspires you, click a picture and tag us, put in hashtag of GOWC 2021, hashtag GOWC 2021, and tag yourself. Please do not forget to mention your name, your grade, and school you're from. We will see your interaction and what your description is like and how much you've liked it. And whoever's the winner will be on top of the leaderboard. The results of that would be announced towards the end of the winter camp. And yeah, and we're looking forward to your challenges.
Thank you, Nishma. And guys, good luck with your challenge upload. I hope you guys win. Guys, let's just turn on our mics once and say thank you, Keon, or bye, Keon. And let's just give you guys a chance to share that using your audio before we close this off. So, Nishma, can you just unmute everyone? Is there a good way to do that?
Yep.
And then, guys, everyone say thank you, Keon, or bye, Keon, and then you can leave the room.
What? You can unmute yourself.
Thank you, Keon. Bye.
Thank you, Keon. Bye.
Thank you, Keon. Bye, Keon.
Bye. Thank you. Bye. Bye and thank you. Bye. Thank you. I just wanted to ask you, like, when we're uploading the picture, what else should we include the details again?
I'll tell you. You'll have to mention your name, your grade,
Yes.
and your school. Use the hashtag GOWC. I'll drop the details here on the chat so that we have your information with us.
What picture do we post again?
Sorry?
What picture do we post again? Our inspiration for I don't understand what the picture we have to post is.
It could be if it's let's say medical science inspired you. You could, if you have drawn something around that line, you could post that up. If you've written or painted anything, you can post that up. Or let's say if you got a chance to, let's say, visit NASA, you can put your picture up and then drop us the information.
Okay.
Yeah, right. Hold on. I'll send the details here again. For your steps, you have to mention in your name. You have to mention your grade, your school, and the hashtag.
Awesome. Thanks again, Keon. I think we can drop off.
Great.
Bye, guys.
Great.
See you guys
Great.
later.
Thanks, guys. Thanks for organizing. Take care. Bye-bye.
Yeah, I loved this session. Bye.
Bye-bye.